Hello, my name is David Giles of High-Text Development Tools, and this is a short presentation on the TESSY Unit Testing Tool from Razorcat. In this example, we'll be using the TESSY Scenario Editor on a pre-prepared example for a circular buffer. Okay, so here we are inside TESSY now. I have a database already open called Circular Buffer, and I'm now about to create my first scenario. I do right-click, I do Add a Module, and I create a name for the module, so it's called Buffer Scenario in this case. Hit the return key and do right click Properties, and you'll notice that we have a little radio button here to determine the kind of test that it will be. So I click the scenario button here, or the component radio icon button here, and I come up into the sources tab and basically select the source files that I want to use within here. So I have one C source file called circular buffer enum.c, and I'll just include the include path. I open up the module now, and TESSY will actually pass the code to make sure everything is okay with that code. And in a unit test, what would be detailed here is a list of all of the functions which TESSY has created. In this case, it doesn't do that because we've created a component test rather than a unit test. So we just have the word scenario on here. I'll just give you a quick look at the source code. Here I just have a couple of headers. I have a miserable types.h and a circular buffer enum.h. So we'll have a quick look at that header file, the circular buffer enum. And what I've done is I've created an ebuffer type, which you can see here, ebuffer status table type, and inside here are 1, 2, 3, 4, 5, 6, 7 different enum types. So I have ebuffer empty, ebuffer as data, ebuffer full, ebuffer overflow, and then I also have no new data available and new data available. And I'll be using this as a kind of global variable to determine the status of the buffer at any given condition. And also a couple of header files for the three functions which we have within the C source code. So if I come back into the C source code, you can see that I have one function called push data in. And this basically takes an unsigned char value and pushes it basically onto a circular buffer, and then it returns from this function with an enum. And as you saw here, the enum will be either ebuffer empty, ebuffer has data, ebuffer full, or ebuffer overflow. So the calling function will know the current status of that buffer. The buffer is actually this variable here, rx buffer, and as you can see it has a size of 8, which is defined here. So there are 8 possible entries into the buffer before we kind of get a buffer full condition. And if we attempt to put a 9th element within the buffer, then we get a buffer overflow situation. So we have the function here, push data in, and basically I push the data into the buffer. The complement function to pop data in is called pop data out, and as you can see here, I basically return the value in a pointer, and I also return with the status value as well. So if we kind of come back to the enums, I've got 2 enums here for the pop function, one of which is no new data available and the other one is new data available, and that means the calling function can examine the return type or the return enum to see whether there's this data here is currently valid or not. So it's a very simple kind of push and pop onto a circular buffer. I also have a flush circular buffer routine which is called initialization, and this basically cycles all the way through the 8 bytes, resets the buffer to 0, and basically the in pointer and out pointer values are reset to 0. Okay, so back to TESSY now. So we've had a good look at the C source code, and now we're going to test it. We're not actually going to do unit testing as such. We may have already done that on these functions, but what we're going to do is test how the functions react with each other. So we're not particularly interested in what the data in counter and the data out counter are doing, or necessarily the value that's stored within the actual buffer itself. But what we are going to test is when we push data onto the circular buffer, and when we pop data off the circular buffer, that the order of data is as we would expect it. We'd also test some of the overflow conditions as well. Okay, so first thing we do, just like with all TESSY unit tests and scenarios, is we have to come into the interface editor. We open this up, and this looks very similar to what it is if we're doing a unit test. You'll notice that we have the external variables, of which there's none. We have the global variables identified here, and these are the sum of all of the variables, the global variables that have been identified from each of the three different functions. So you can see these are the functions: flush circular buffer, pop data out and push data in. We also have the enum, which is detailed here. So if I just click on the plus icon, we can see what numbers have been associated with each of the different enums. But what you will notice different is that for the component functions here, we have a new little icon, which is an eye with a red line through it. By default, the variables that are used within that function are hidden, and those variables are detailed down here. If we want to make them available such that we can create some tests so we can actually look at those variables, then we can do that here. So by doing right click, we can show the variables used by this function. For this particular example, we're not particularly interested in what's happening with the variables, so we won't select that feature. I close this down. We'll be asked to save our changes, which is yes, and now we come up into the scenario editor now. So on the right hand side, this is where we create our test cases. So instead of it being a test case, it's actually a test scenario. So I do right click, add scenario, and as you can see here, we have a white icon to represent the scenario, and it's currently white because there's no valid test data in there. I'll double click on this, and because there's no input variables and there's no return variables, we can't actually see anything within there, which is fine. So I'll close that down. Now what's new, what we've not seen before, is the scenario editor. So if I bring up the scenario editor, which is this icon on the toolbar, so when we click on that icon, the TESSY Scenario Editor is pulled up for us. You'll notice on the left hand side here that we have scenario, and here we kind of have the functions which are available to us. These are all the functions which aren't defined as statics. If you have static functions within that C module, these will not be available to you. And what TESSY actually needs, it needs a kind of work task. You'll see that there's this little icon here, which basically is a function which TESSY calls between each of the different steps. Now we need to create this function if we don't have one that we want to use. So what I'll do is I'll create a dummy C file which creates a blank void in and void out function which actually does nothing. TESSY needs this to call to be able to manage the operations. So if I close the scenario editor just down for now, and then I'll go back into the module properties, and then I'll add in a new source file which is basically just a dummy function. So I've got one here called tickvoid.c. Click on OK. The TESSY analyze that, we'll reuse it. Now we'll have one extra function, which is this little tick function here. So I'll accept on that and commit to it. Basically, when I open up the scenario and come into the interface, that you'll see that we'll kind of have one new component function now, which has got this this void function in. If I do right click, edit source file, and click tick_void.c, you can see it's just a dummy function with very little inside it. Okay, so back to the scenario editor. Open the scenario editor up again. Now you'll notice that we'll have one extra function in here which is called tick, and this is what's required by TESSY to be able to synchronize what it's doing. So what we'll do, is we'll highlight the function and then we'll come up to here, so with the set as the work task, and we have a little cog icon now which is turned blue. On the right hand side here we've got some a kind of sequence, if you like, for the scenario. So what I'm going to do is I'm going to create some time steps. So insert time step, insert time step, and insert time step. These basically allows TESSY to sequence through a whole portfolio of tasks. At each of these time intervals it actually calls the work function, which is tick. So in this particular instance it's void in and void out, and it's not particularly doing anything useful. The other thing to note is that we've got some timing references on here: 10 milliseconds, 20 milliseconds, 30 milliseconds, etc. This actually bears no correlation to the real world time, but it just allows us to, in our minds, configure a sequence with one after another. In this particular case, what we'll do is we'll take the first function, flush circular buffer. We'll click and hold the left mouse button and bring it over into the 0 milliseconds. So at 0 milliseconds, the tick function is called, followed by the flush circular buffer, and the circular buffer then hopefully will be completely empty. At 10 milliseconds I can put some data in, so I grab and hold the push data in and drop it onto the 10 millisecond icon, and as you can see here we have a little caution symbol which tells us that we've got incomplete data. If I open up the screen a little bit so we can see this in a little bit more detail, what we have is, if I highlight this particular item, is that new data is an input parameter which is an unsigned char value, and I can actually enter a value for that in this box. So we'll have a value of 10. After calling this function, if you remember, it returns an enum. So what we can do is we can put the return enum value in here. So if I just quickly pull up the C source file that's got that in there, which has that in there, circularbuffer.enum. So that should return eBuffer has data. So if I copy that item back into the TESSY scenario editor and paste that enum value in there. So basically at 10 milliseconds we're going to push a value of 10 into the circular buffer, and basically the return value from that is going to be eBuffer as data. I can actually copy this as well now, so I can do copy and come down to 20 milliseconds and do paste, and we can basically have the same situation going on. In this case obviously it's 10 because I've just copied that from the previous test case, but what we'll do is we'll kind of have 20. And again we would expect the circular buffer to also respond with having data. I can also have more than one line on here, so I can do copy and then I can do right click and then paste, and I can put another value down on there. So I can have more than one item on each of these lines if I want to. I can also highlight two together and do copy and then do paste. So I can change these now to 30, sorry, 10, 20, 30, so that one's 40. And we'll have that one as 50. So I've now got 1, 2, 3, 4, 5. So we'll kind of have another 2. So that should paste another 2 for me. 60, and another one here of 70. And then what we'll do is, so with buffer has data 1, 2, 3, 4, 5, 6, 7. However, when I do the 8th one, so what will happen is when we push the 8th value onto the stack, this buffer, we now have eBuffer full, and that should now change to eBuffer full. And I can also check the overflow condition as well, and we'll kind of have that one. So we'll put 90 in, and that one should now change to eBuffer overflow. Okay, so we now have eBuffer overflow in that final piece of data. So the sequence is circular buffer is going to be flushed, then we're going to push 10, 20, 30, 40, 50, 60, 70 onto the buffer. The status of the buffer changes when we put the 8th element on, it changes to eBuffer full, and then when we push or attempt to push the 9th one on, we get an overflow situation. Okay, so that forms our first test scenario, and now we can test this using, in this particular case, the GNU compiler. So if I close the scenario editor down and I come back into here, We can also edit the description and specification from here as well. So if I double click, we get the description box. So here I can just put push data in only as the description and click on save and come out, and as you can see these fields have updated here. To run the test is exactly the same it is for running a unit test. Click on the lightning rod, we'll generate the driver, we'll click on run. If we want some instrumentation through the functions, we have to go for test object and called functions. So I've highlighted that in this particular case, and now we click on execute, and TESSY goes away and executes the test using the standard GNU tool. Okay, so the test has executed successfully. As you can see here within the scenario editor, we have green tick symbols against each of the time steps. Here, for example, 10 milliseconds is fine, push data in, eBuffer has data. We also have the tooltip as well. So here, if I kind of hover over there, then the actual value for the enum was 1 and the expected value was 1. If I come down to here, we can see the actual value is 2 and the expected is 2, and so forth. If I come into the monitoring icon, you can see that we get a similar kind of report as if we had for unit testing. So scenario number 1, these are the functions. That was the one which I called initially, and we have 100% path coverage through there. Pop data out, we didn't execute within this sequence, so obviously we have no code coverage information. Push data in, we did call, and in fact we went from having no data in there to actually an overflow condition. As you can see here, we don't quite have 100% code coverage. If I just highlight this diamond symbol, and there is one scenario there which I've not fully covered, which I can go back and later amend to include. So close the coverage viewer down, and that's the first scenario. So okay, that's the first scenario that we've done. Let's try something a little bit more interesting. We want to both push data into the circular buffer, and we also want to pop data from it as well. We've done a lot of the hard work already, so what we'll do is we'll just copy that scenario and then we'll paste it below. And then if I double click to edit, so we'll kind of have push data in and pop. Click on save. So I've got some text to better describe that scenario, and I come up into the scenario editor. Okay, so we're back now into the scenario editor, and you'll notice that we have not just one scenario on the left here, we have two. So what we'll do now is we'll shuffle some of these around. So we'll move all these up into the one scenario, which you can see here. So what we'll do is we'll push 8 blocks of data on initially. So let's get these in the right order. So we got 10, 20, 30, 40, 50, 60, 70. I'll copy 7. So we got one final one, which is 8, and I'll come down and change the value to 80. So that one changes to eBuffer full. What we'll do is we'll leave that one in there. That will give us a wrong result, because it should go 10, 20, 30, 40, 50, 60, 70, and when we get to 80 it should be buffer full. Or I'll just leave that one there so we have a failed test case. Okay, so now we'll kind of have a look at what's actually been stored within the circular buffer. So we take this function here, pop data out, and drag this down onto the 20 millisecond step. And similar kind of scenario really. Here we've got the return value, which is an enum. So I can quickly come into the source code. I'll copy and paste the enum value, Control C. Back into the scenario editor and paste this down into here, so new data available. We'll also need to create a pointer for us to receive the data, and the way that we do this is using the declarations and definitions. So first of all we'll define it. So it's an unsigned char, and we'll call it my helper variable is 0. Just copy that now to make it a little easier into the declarations box, and this is now declared as extern. So extern unsigned char my helper variable. So I have this dummy 8-bit unsigned char variable, which I can use now to receive the data from this function. So I have to put the address, because it's a pointer, of the variable, which is my helper variable. Okay, so click on save. And now what we need to do is just need to test that value, that variable, to see if we have the correct value in there, and we do this using evaluation macros and a C code fragment. So by clicking on this icon here, we've created a C fragment. We want to do the pop before we're the C code, and in the C code over here do right click, which brings up all the evaluation macros for us. So if I do first value, the value that we're going to check is my helper variable, and we would expect that to be the first item on the stack, which is a value of 10. Okay, so you can see now that we've got some C code in there, which is primarily an evaluation macro. So I can copy that and paste that into other time steps as well. So let me create a few more time steps here, and then we'll do right click paste, right click paste, right click paste, a few more. Could do with 9 really. Okay, so that's 10. That should be 20. And that's the second. Third. Fourth. Fifth. Sixth. Eighth. And in fact what we'll do is for the 9 one, we only need the first item, the pop data out, because we know that there's no new data available there. So we know that changes to no new data available, and no data is actually popped off the stack, so we don't need the evaluation macro. And what I'll do is I'll just delete these unused items and click on save. So just double check 10, 20, 30, 40, 50, 60, 70, 80. They're all new data available apart from the final one, which is no new data available. Okay, so that's test scenario number 2, and this should fail because it will fail on this line here. So I'll close down the scenario editor, come back into TESSY, I'll highlight the 2 test cases, click on the razor cat symbol and execute the test. And by default we always show test scenario number 1. So if we highlight test scenario number 2, you'll see that against the 10 millisecond step we actually have a problem, and you can see here that it's been correctly identified as the final item in the row, and push test data, it should have been certainly for the E buffer should have been 2, which is buffer full, and we actually got 1, which was E buffer has data, which we expected, and all the other ones are correct. And again we can come out of the scenario editor, we can pull up the monitoring icon, and this time for pop data out we actually do get some code coverage. Not complete coverage, this diamond here is still requires an additional test case here. That now completes the first example for the scenario editor. Thank you for listening. For those of you in the UK and Ireland, please contact me if you require additional information. My email address is dgiles@hitex.co.uk. For those of you outside of UK and Ireland and you require additional information, please contact my colleague Frank Buchner at frank.buchner@hitex.de. Thank you for listening.